All right, we're going to talk about naming covalent compounds. But in order to do that, we need to understand what that means. So far, we've talked about ionic compounds. In an ionic compound, you have a cation. A cation becomes a cation because he's given away one electron or more and has a positive charge. He gives his electron essentially away to the anion. Chlorine has 7 outer shell electrons. When sodium gives his away, he now has 8, one of them having been sodium's, and they have that attraction. Those are ionic compounds. In a covalent compound, the electrons are shared. Now remember, we defined electronegativity as how sexy an atom is. And the sexier the atom is, the higher the electronegativity, the harder they pull on other people's electrons. Chlorine has a high electronegativity, so he gets that electron all the way over here in his space. Sodium has a low electronegativity. But what if those electronegativities are similar and they pull similarly? For instance, if we have carbon dioxide, carbon we know has 4 outer shell electrons. Oxygen has 6 outer shell electrons. Oxygen needs 2. So he takes 2 from carbon and pulls them inside his shell. This guy does the same. Carbon needs 4 electrons, 2 from each oxygen. So now if we count, we have 1, 2, 3, 4, 5, 6, 7, 8 around that oxygen. 1, 2, 3, 4, 5, 6, 7, 8 around that oxygen. And 1, 2, 3, 4, 5, 6, 7, 8 around the carbon. Covalent compounds form when electrons are shared. All right. So we're going to name them a little differently, and that's our clue. That's one of our clues that it's a covalent compound. The other clue, if I go back to this other page, now bear with me, let's see if I can find it. Yay! We'll make all the ink go away. Remember, I had you color yellow. We colored in yellow all the monoatomic on an earlier page. And I don't remember which ones are monoatomic and which ones aren't right off the top of my head. And then we did blue for the ones that were multivalent. So now we're going to look at these green ones over here. These green ones are monoatomic nonmetals. But they can also bond with each other. An ionic bond, with an ionic bond, you have a metal and a nonmetal, a metal and a polyatomic ion, or you could have a polyatomic ion with a polyatomic ion with ammonium. So covalent is different. Covalent, you're going to have 2 nonmetals. From here. The prefix co means to share. Valent refers to valence electrons. Only nonmetals can share electrons, and that's because their electronegativity is so close to each other. Now, we use prefixes to tell us how many electrons we're going to, or how many atoms we're going to use. One, the prefix for one is mon, and we only use it for the positive, for the first element. I don't know even why positive came out there. The second element. If it's the first element, like carbon monoxide, we don't put the mono on the first element if it's a single, because it's redundant. It's accepted. It's kind of like the anything times one is itself. We only use it for the second one. 2 is di. 3 is tri. 4 is tetra. Think tetris has 4 shapes. 4 is tetra. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. These are all prefixes, and we use them to describe what element, or the number of that particular element. All right? So let's try a few. If we're given the name, the first one, carbon monoxide, there's no prefix that tells us that there was only one carbon. Here the prefix is 1, so we write O, and it's 1. Of course, we can just simply write it CO. We don't have to put the 1 there. Sulfur, again, we don't have a prefix, so that tells us that it's 1. Hexafluoride. Fluorine has 6 atoms in the compound. So he's SF6, sulfur hexafluoride. Tetraphosphorus, tetra means 4. Decoxide, that means 10. Fairly simple. Going the other direction, we have 1 carbon. You would think, I got to put a mono on there, but because it's the first one, we don't. His name is carbon. We have 2 oxygens, so we say dioxide. We have 2 hydrogens, dihydrogen. And we have 1 oxygen, monoxide. Notice we're using "ide" again for the ending. We have 1 nitrogen. It's the beginning one, so we don't need mono. Nitrogen triiodide. I-O-D-I-D-E. All right. So let's give it a whirl.